Hello, everyone. In this video, we will be going over the longitudinal actor-partner interdependence model. So this is a longitudinal extension of the base actor-partner interdependence model, where we are going to be using time one predictors to predict time two outcome variables. So there's going to be a longitudinal component to our model where we are going to have a lagged association. So if you're familiar with the cross-lag panel model, we're going to have those cross-lagged effects. And in the APIM, we call those actor effects for the most part. All right, so we are going to be using um, lavaan to estimate that within R and R Studio. So up here, you will see I'm using Haven and lavaan for these analyses. So lavaan will be the SEM models that we run, and Haven brings in my SPSS data file. So what we will do first is we'll walk through the syntax. I've created my model object, and it's called LAPIM for longitudinal APIM, but you can name this really whatever you want. And then I'll put in quotes. You put in your first quote, and then a second one will pop up, and then you type in your model in between. So for this analysis, we're using a large national data set looking at attachment security and conflict resolution styles among heterosexual couples. You will see that we have an M in front of half the variables for male and F in front of the other half the variables for female. And so our dependent variable is disengaged. So we'll say just for ease, I have W6 at the end, so we'll call that wave 6, and that'll be time 2, and then we'll have wave 5, which will be our time 1. So this measure assesses males' perceptions of how disengaged their female partner is during conflict. And so likewise, the female partner is evaluating the extent to which they perceive their male partner is disengaged during conflict. And then we'll be measuring attachment security, just using a secure attachment measure. And we have that for both males and females. And so you'll notice here we have attachment security at time wave 5 or time 1, and it's predicting variance in disengaged conflict resolution styles at wave 6, which is our time 2. But you will also notice that we have a disengaged at time 1 or wave 5. And so that is that autoregressive parameter that I had mentioned, or in APIM speak, that is generally called an actor effect, right? And so in the cross-lag panel model, it's time 1 depression predicting time 2 depression. In the APIM, it's male security predicting male disengagement. Right? And so this allows us to establish a longitudinal relationship where this value, this parameter estimate that maximum likelihood generates for us, will account for a specific proportion of variance in disengaged at time 2 or wave 6 above and beyond what is accounted for by male disengaged at wave 5. And this allows us to say that there is a longitudinal relationship. So we could kind of delete wave 5 here, and we could have just secure and disengage. But what happens is when you look at the findings, the patterns of correlations will more closely resemble cross-sectional analyses than longitudinal analyses, as if you had this autoregressive effect in your model. The autoregressive effects, especially for perception-based measures, I perceive my partner to be loving, I perceive my partner to be supportive, I perceive my partner to be warm and nurturing. All of those types of measures tend to have quite stable autoregressive effects, generally between 0.4 and 0.6, although I've definitely seen, 0.3s and 0.7s and 0.2s and 0.8s. Generally, they're going to have a fairly strong beta coefficient or regression coefficient, which means they're going to account for a lot of variance. And that could be overlapping variance with male security. And so male security might not actually predict male disengagement over time. Likewise, we might not have a partner effect either, where male security is predicting female engagement over time, which we will see down here. All right, so to establish those longitudinal effects, we have male security at wave 5 and disengagement at wave 5, predicting male disengagement at wave 6, which is approximately 1 year later. And we have the exact same thing for females. Mm. So now we are going to estimate our partner effects. So now we have male disengagement at wave 6 being predicted by female attachment security at wave 5 and female disengagement at wave 5 or time 1. So one thing you'll want to think about when doing longitudinal models, and this is going to be particularly true for dyadic data, is when you have a longitudinal association like we have, we are actually going to have partner effects of those time 1 variables. So we are going to have a partner effect of female disengagement, predicting male disengagement a year later. And that is above and beyond, that parameter is above and beyond female attachment security, male attachment security, and male disengagement at wave 5. All right. And so we have to think theoretically, does that make sense to us? Does it make sense to have this parameter in the model? And for a lot of contexts, it's probably going to do that. We're doing kind of couples here. That's our sample. And so when we think of couples, there's a really high level of interdependence, right? Particularly for couples who have been together for longer and longer and longer. Those who are married, those who are cohabitating and things like that. There's a high level of interdependence. If we were doing this study on perhaps siblings, for example, siblings in adulthood, they generally they don't live together. They might not talk all that often even. They might talk only, a few times a week. It might be a few times a month, depending on how close they are. So there's going to be a much lower level of interdependence. And so if I were doing the same study on siblings, I might not control for the partner effect of the opposite of the other sibling at time 1. I think that all of the variance for one sibling is going to be captured by their own attachment security, their siblings' attachment security, and their own previous levels of disengagement. Luckily, there should be theory that's driving that a priori hypothesis, but in structural equation modeling, this becomes a very much a testable hypothesis where we can constrain this effect to be 0, and then we can freely estimate it, and then do a likelihood ratio test to see whether or not our theoretical and conceptual underpinnings are empirically supported in the data. All right, so next we have partner effects for both. Again, you'll notice that we have the female and male security attachment security, and those are our primary independent variables. And then again, we have those control variables for the other partner. Just as in the baseline APIM, we want to correlate our residuals on our dependent variable, and we do the exact same thing for each of our 4 predictors on the independent variable side of the equation. So here we have our fit object, and so I'm using robust maximum likelihood. I don't have any missing data with these particular variables, but others in the data file have missing data. So I have missing equals ML. That employs full information and maximum likelihood. And then by default, I just simply always include the mean structure. I always do mean structure equals true. And then I want the summary statistics. Oh, excuse me. And I want R squared, standardized coefficients, as well as fit measures. All right. So we can go ahead and we can run this. And this model, again, it should be saturated, right? So we are estimating all of the parameters that we possibly can. So we should have 0 degrees of freedom, which we do. So this is just a nice way to double check that your syntax is correct and that what you are telling lavaan to do is what lavaan is spitting out to you. Okay. So when you have 0 degrees of freedom, all of your fit statistics are relatively meaningless. The only one you might want to pay a little bit of attention to is your -2 log likelihood. But even at this point, that's not all that relevant for the things that we are trying to do um, in, um, in this demonstration. So we will scroll down and we will take a look and see what we got. So we see here male attachment security does not have a significant relationship with male disengagement beyond prior levels of disengagement. And as you can see, our standardized regression coefficient is 0.58, which is pretty substantial. So that means there's going to be a considerable amount of variance in disengaged at wave 6, accounted for by disengagement at wave 5. So there's going to be some stability over time. And male attachment security is not a significant predictor of that. So likewise, for women, we have women disengagement at wave 6. That's being predicted by female attachment security at wave 5, as well as female disengaged conflict resolution styles at wave 5. And so what we can see here is we have a significant effect. All right. So female attachment security is a significantly predicts variation in female reports of their partner's level of disengagement 1 year later, above and beyond female reports of their partner's disengagement 1 year prior. Right. So essentially, what that translates to is the more women have a secure attachment, the more they can remain cool, calm, and collected in the face of conflict, the more they don't worry about their partner abandoning them, the more they're not trying to distance themselves from their partner. The lower or the less they evaluate their partner to be disengaged during conflict 1 year later. Right. We have a fairly small regression coefficient, and we can see that the p-value is just under 0.05. And so we have a sample of, I believe, 627 couples. So we have a very large sample. So it is not surprising that a smaller beta weight like -0.07 is statistically significant. Right. So let's take a look at all of these were actor effects thus far. All right. And so let's take a look at the partner effects. And so what we see here is something else that's really interesting. So we see that we have a significant partner effect, that women who are more secure at time 1, men report that their female partner has lower levels of disengagement during conflict 1 year later, controlling for both members' previous levels of disengagement as well as male attachment security. And if you think about this, this makes perfect sense. Again, when we think theoretically about a secure attachment, we are comfortable kind of being on ourselves. We're also comfortable being in a relationship. We value intimacy and closeness, but we're not overwhelmed by it, and we don't push our partners away. And so the more and more women can embody those characteristics, the more and more, or less and less, I should say, that men report that they distance. Because if women were more avoidantly attached, they had higher levels of attachment avoidance, we would probably see this be really significantly positive. But because they can stay cool, calm, and collected in the face of conflict, their partners say, "Oh, they evaluate them as, oh, hey, you're present with me when we're arguing, when we're going back and forth." Right. So again, these associations make a ton of sense. Interestingly enough, and again, this was kind of my hypothesis, is that we would not potentially have a partner effect. I wanted to test it just to be sure, but for the most part, I probably would have expected that though the attachment security and previous levels of within person, that autoregressive control for males, which would be male disengagement at wave 5, would be the biggest contributor. And as you can see, um, the more women perceive men to be disengaged at wave 5 is positive, but not significantly related to men's reports of women being disengaged 1 year later. Right. So here we have a similar process happening for men. So men who are more securely attached, they report that their female partners report that they are more present, that they are less disengaged 1 year later. So again, we have another significant partner effect here. So we're kind of seeing a pattern where the higher each dyad member is in attachment security, the less likely or the lower levels their partners report them to be disengaged, which again makes a ton of theoretical sense. And as you can see here, that partner effect of male disengagement is non-significant. And so that is the basic longitudinal APEM. So now what we will do is we can actually fix these parameters to be 0, um, these non-significant partner effects. So I am fixing female disengaged at wave 5 to be 0 when predicting male disengaged at wave 6. So so that is, I fixed 2 parameters to be 0 here. That is this guy right here. All right. And that is this guy right here. All right. And so now what we're going to do is we're going to add 2 degrees of freedom to our model, because we are fixing these paths to be 0. We are placing constraints on these paths, and therefore we are afforded 2 degrees of freedom, so we can begin to evaluate model data fit. Just know that when you have small degrees of freedom, many of your test statistics are going to be either exceptionally well behaved and give you all the good statistics. Your CFI and your TLI will be 1, your RMSA will be 0, or they will be exceptionally poor, very poorly behaved. They're going to be exceptionally not very well behaved. What's going to happen is your RMSA can jump up to 0.10 or 0.15. So your RMSEA tends to be actually a pretty terrible indicator of model data fit when you have few degrees of freedom. Dave Kenny did a 2015 paper on the RMSEA in low degree of freedom models, and that would be a wonderful resource for you to cite if you want to know more about that. Another reason why I ignore RMSEA when I'm doing growth curve models and just estimating that unconditional model, because again, that's another model that just has very, very few degrees of freedom. And so RMSEA is either extremely happy or extremely volatile. So now we will examine kind of what happens when we impose those constraints. So we can make this a little bigger. And not surprising, actually what I'm going to do is, to do this correctly, is I'm going to use maximum likelihood. I'm going to actually ignore all of that because and the reason I'm doing that is with robust maximum likelihood, you need to incorporate your scaling correction factor into your chi-square difference tests, and that is not the purpose of this video. So I will use just traditional maximum likelihood in estimating the likelihood ratio test. So as I said earlier, we have 2 degrees of freedom. We've imposed 2 constraints. The constraints are constraining those partner paths of the covariates to be 0. And we can see that it does not significantly harm the model given our chi-square difference test. right? And as you can see, our RMSEA is very well behaved. But if you take a look at that confidence interval, it is exceptionally wide. That is not a tight confidence interval that we typically want with RMSEA. And part of that is due to lots of imprecision with the RMSEA in these low degree of freedom models. All right, so we will kind of scroll down and we will take a gander, and not much has changed. You see these p-values and these parameter estimates have shifted a little bit, right? Because even though there were small parameter estimates, they were accounting for just a smidge of variance in our dependent variables. These guys were when they were freely estimated. And so now we're taking that away. And so now that's going to change the parameter estimates ever so slightly, because again, SEM is a systems of equations approach where you tinker in one part of the model, it's going to send ripple effects into every other part of the model. We just want those ripple effects to be extremely tiny and not these monsoon-like tidal waves of effects. Right? And so that is the chi-square difference test in the likelihood ratio test. And again, this is something if you uh, uh, theorize that you're not going to have those significant partner effects, again, it becomes a testable hypothesis, and you absolutely should conduct those tests. Oftentimes in the literature, those tests are kind of ignored. They are not endeavored on, or they're kind of lumped together with other parameters where they do omnibus likelihood ratio tests. And I don't really know what to make of those. But that is another discussion for another day in terms of multiple degree of freedom likelihood ratio test results. But essentially, that is the idea behind the longitudinal actor-partner interdependence model. I hope this video has been helpful in helping you learn how to estimate the longitudinal APIM within lavaan. Appreciate you watching. Thanks so much.